Hi, I'm Raghu and welcome back to another session in the series of programming a Raspberry Pi Pico using Python. Let's now build our first module. We'll start with one input and two output devices. The input device which we'll be using is a push button. The two output devices are A. LED and B. Buzzer. Out of these two, the LED is an onboard device which is built into the Raspberry Pi Pico. The push button and buzzer are external devices. First, let's just have a quick look at what the push button, buzzer and LED are. A push button is like a regular switch. Only difference is that in a regular switch, if the switch is pushed, the electrical state changes and then it always remains in the new state until the switch is pushed again. In a push button, however, when the button is pressed, the state changes, but only till the button is held pressed. If you take your hands off the push button, then it gets released and its state goes back to the old one. A buzzer is a device that produces an audible beep when an electrical signal is passed through it. A buzzer has a positive pin and a negative pin. When you connect the pins, you should connect them with the proper polarity. An LED is a device that produces light when electricity is passed through it. LED stands for light emitting device. An LED has a fixed polarity of anode and cathode. The anode has to be provided with a positive voltage while the cathode must be connected to negative or ground. Let's now connect these devices to our circuit. If you're using Y0 boards, then the connections are very simple. Connect a 2-pin RMC wire from the pins marked as PB on the Y0 Pico board to the pins marked as push button on the Y0 PB buzzer and LDR board. Connect a 2-pin RMC wire from the pins marked as buzz on the Y0 Pico board to the pins marked as buzzer on the Y0 PB buzzer LDR board. In case you're not using the Y0 boards, then you may directly connect the pins from the Raspberry Pi Pico to the devices. Just follow the instructions on the screen. Now that we made the connections, let's write code for this module and try it out. Open Thorny IDE. In the code section, start typing the code as seen on the screen. The first two lines have two import statements. Now's a good time for me to explain about Python's import statements and modules. One of the reasons why Python has become so popular is due to the fact that many people have already written code for different applications. And as a programmer, you can use these functionality without having to write the code all by yourself. Of course, you can use the code only if the author allows it. So how do you reuse such code? When any developer writes code that he or she wants to expose to the public, they package it in the form of modules. When you want to use this code, you will simply import these modules. A module is typically a file consisting of a Python code. A module can define functions, classes, and variables. If you want to import only one class, then you would say from module name, import class name. And that's what we've done in our first line of code. From the module called machine, we are importing the pin class. And in the second line, when you say import time, you're importing everything that's in the time module. If you want to, you can also import specific functions from a module. In the next line, I said LED equals pin, 25, pin.out. LED here is a name of a variable. In this statement, I'm creating an LED variable which is of the type pin. This pin is connected to GPIO 25 of the Raspberry Pi Pico. The last parameter, which is pin.out, configures the GPIO pin as an output pin. Recall that if a GPIO pin is configured as an output pin, then the microcontroller will send information to that pin. Pin number 25 of Pico is connected to the onboard LED of the Raspberry Pi Pico. Based on the configurations that we did in this line of code, we will be able to control the onboard LED from the Pico. At this point, I would like to highlight one concept that I mentioned about in a previous Python tutorial. Variables in Python are dynamic. That is, you don't have to declare a variable beforehand. In a programming language like C++ or Java, I would have had to add another line before the statement, something like pin LED. That is not necessary in Python. On the same lines, we create a second variable called BZ, which is connected to GPIO pin number 13. This is also an output device. In this case, we had to connect an external buzzer to the microcontroller. In the next line, we declare a variable for the push button. We call this as PB and assign it to pin number 14. By using pin.in as a second parameter, we made this as an input pin. Recall that the input devices, usually sensors, feed data to the microcontroller. In this case, the push button checks whether the user has pressed the button or not and gives information to the Pico. The push button will tell the microcontroller whether the pin state is high or the pin state is low. But wait, there's a third parameter for the PB variable, which is pin.pullup. Now what is this? When a GPIO is configured as an input pin and is not connected to any circuitry, there is no guarantee that the pin state will either be high or low. That is because the microcontroller can interpret any noise or any other transient current flow to either be high or low. So when I use the parameter pin.pullup, I am telling the microcontroller this. Hey buddy, please connect this pin to the source voltage through a resistor. So if the user doesn't connect this pin to either high or low, the microcontroller reads this as high. So that's nice. We've done the initial configuration. Before I get to the next line of code, I would like to take a short detour and talk about high and low. In the last few minutes, I've been using the terms high and low. What are these? In digital electronics, any pin can have only one of these two states, either high or low. Think of these as either true or false. If the voltage of the pin is below a certain threshold, then the pin is said to be in low state. If the voltage of the pin is above a certain threshold, then the pin is said to be in a high state. So now let's move on to the next line of code. The next statement is while true. While is a looping statement in Python. I'll explain about this just a little after I finish explaining about the code itself. For now, just remember that by using while true, I've told Pico that it should execute all the lines in the block forever. So in the line after the while true statement, we check the state of the push button and hold the state in a variable called PB state. In MicroPython's pin class, the method or function value gets the digital state of the pin. This value is stored in the variable PB state. The pin.value can either return 1 or 0. This means the push button is in high state while 0 means that the push button is in low state. In our circuit, we've connected one pin of the push button to GPIO 14 and the other pin to ground. So when the push button is not pressed, the state of the pin will be high. When the push button is pressed, GPIO 14 gets connected to ground and the state of the pin will be low. The if statement compares the value of the PB state with 0. If the value is equal to 0, it means that the push button has been pressed. And when the push button has been pressed, we turn on the buzzer and the LED. The pin class's on method sets the state of the pin to high. By setting it to high, we are turning on the device connected to the pin. If the button has not been pressed, then we turn off the buzzer and the LED. Finally, we use the time.sleep bracket 1 to give 1 second rest to the microcontroller. During that time, the microcontroller does nothing. That's it. The code is ready and you can now run it. Connect the Pico to your computer and click the run icon on Thorny. If you press the button, you'll see that the LED is turned on and the buzzer starts beeping. If you release the button, the LED turns off and the buzzer stops beeping. Now let's get a little deeper into the different flow control statements of Python. In Python or any programming language, a while statement is used to execute a set of instructions continuously in a loop. A conditional statement follows the while keyword. The Python interpreter evaluates this statement. If the condition is true, then everything in the while block is executed. So why have I given the conditional statement to be true? I'm not evaluating anything here, I'm just using the word true. An embedded system exists to perform a specific set of tasks. This must be performed from the time the system starts till it is switched off. In short, the tasks have to run forever. And that's why I said true. For example, in our case, we are continuously checking if the push button is pressed or not. If it is pressed, then we turn on the LED on the buzzer. If it's not, then we turn them off. Apart from the while statement, Python supports another looping construct. This is the for statement. The for statement has the syntax for iteration in range. A range could be a range of numbers, a sequence of items, for example, a string. A string is a sequence of characters. An array, that is a list or a tuple. When a for loop is executed, the block beneath the for loop is executed for each item of the sequence. If you have a range of numbers, then when you say for bracket I in range 5, then the block of code below the for statement is executed for all the numbers 0, 1, 2, 3 and 4. If you use the for statement with a string, then the block is executed for each character in the string. Likewise, if you have an array, the for statement is executed for each element of the array. An array in Python could either be a list or a tuple. We've seen so far that when the Python interpreter encounters a loop statement, be it a while statement or a for statement, it executes each line in the block that follows, till the last line in the block. Well, that's not always necessary. If you want, you can branch out of the pattern. The two statements to do this are A, break, and B, continue. Within a loop, if the interpreter sees a break statement, then it will exit out of the current loop. That is, the remaining lines will not be executed and it will move on to the statement after the block. If it sees a continue statement, then it will stop execution at that point. The remaining lines of the code are not executed. But it will not come out of the loop. Instead, it will go back to the while statement or the for statement right in the beginning. In a while statement, it will go back to the first line and evaluate the condition again. In the for statement, it will go to the next iteration in the range. The next flow control statement in Python is the if statement. It is very straightforward. First, check the statement which follows the if keyword. If the statement is true, then execute the block of code that follows the if statement. If the statement does not evaluate to true, just ignore the block and move on to the next set of code. Now what if you want to execute one block of code when the statement is true and another block if it isn't? Python has the else and elif keywords for these. These are again self-explanatory and intuitive. After a block of code that follows an if statement, you could have an elif statement. The elif keyword will have a statement that again has to evaluate to either true or false. The lines of code under the elif block will only be executed if the statement for the elif evaluates to true. Finally, after all elif blocks, you will have an else statement. The block under the else statement is executed when all other conditions have failed. The else keyword cannot have any statements following the else keyword. To summarize the if, elif, else blocks, you're telling the Python interpreter that if condition A is satisfied, then do the first set of instructions. Otherwise, if condition B is satisfied, then do the second set of instructions, and so on. Finally, if none of the conditions are satisfied, then execute the lines of code in the else block. A quick short note about conditional statements. All along I've been using the term if condition evaluates to true. So how do you evaluate a condition? By using the comparison operators. The comparison operators are quite straightforward and there is no need for an elaborate explanation. It is similar to arithmetic evaluation. Is equal to, not equal to, greater than, and so on. When we declared the variables LED, BZ and PB, we created them as pin type variables. If you're from a structured programming background like C, you'd have declared these variables as int, float, boolean, etc. So what do you mean by declaring a variable as pin type? What does the pin data type mean here? Pin is actually a class. Python has full support for object-oriented programming. While the OOPS concept is quite vast, I'll just give a short introduction to what it means. In object-oriented programming, data and functionality are encapsulated into one unit called a class. The class has everything required to emulate the working of an object. For example, the pin class has everything that's required to control a GPIO pin. Setting the pin as an input or output, changing the state of the pin, reading the state of the pin, etc. When variables of a class are defined, these variables become object instances of the class. In most OOPS languages, the functions of the class are called methods, while the variables are called fields. You can invoke the public methods and fields by using the dot notation. Example, led.on, buzzer.off, etc. So let's recap all that we learned in this session. We learned how to import Python modules. We learned about how to configure GPIO pins, read values from and write values to these GPIO pins. We then learned about push buttons, buzzers and LEDs. We got to understand more about Python's looping constructs like while and for. We also learned about Python's if block and comparison operators. Hope you enjoyed this session and have got a good understanding of the concepts that we learned here. So let's move on to the next session in this series of programming a Raspberry Pi Pico using Python. So see you soon.